Hello everyone. Today we are going to understand how to integrate a RAG service into our GenAI application. In our previous videos, we have understood what is GenAI, what is RAG, what is embedding, and all of those basic stuff. We also have a hands-on video where we have implemented basic prompt engineering techniques and we started developing the first GenAI application. Now it is time for us to enhance that application to integrate RAG. So we are going to integrate vector store based RAG service into our application. So if you remember, we were building an application which will help you plan your trips. We called it the Trip Planner AI. So earlier, based on users' question and whatever prompt we had defined, the model was giving suggestions on which place they can visit, what are the different cuisines they can try, what are the different activities, what would be the budget, and stuff like that. So now what we are doing is we are giving an additional document to the model which has detail of what offers we are giving currently to our customers. So based on users' question where they are traveling, the model is going to try, or not model, the application is going to try to retrieve the relevant offers for that given location, and then it is going to tell the users, hey, this is what offer we are having currently. And if there are no offers, it would say there are currently no offers applicable for this location. So this is what we are trying to do today. So I will start with showing you what all different things I have changed in this application code from our previous videos. As usual, I will definitely drop a link of this updated code base as well. I'll possibly put a link of a pull request also so that you can clearly see what changed in the application. So if you have been following my code base to build your application, the PR will help you easily understand exactly what changed. You can also take a latest clone of my code if you want to save time and then get started with hands. Now let's start looking at what all things changed in the code. So first thing, the main.py, I have cleaned it up now. So it is very simple. It just takes user input now, and then all of the responsibility is now transferred to this trip planner class. We will look at it. It basically validates the input query and then passes the query to the trip planner's get response method and prints the model. So I have made this main.py really clean. Let us go to trip planner.py where a lot of work is going on. So in TripPlanner.py, we now have a new version of the prompt. Earlier we were using prompt version v3. Now we have moved out to prompt version v4. We will talk about that shortly. We were already using the Llama LLM instance. Currently, we are also using additionally vector store. So vector store, there are multiple free options, multiple open source options what you can try. So I have used FAISS vector store. We will again talk about that as well. We have a separate TUF file which is now added, which especially talks about the FAISS vector store. And we continue to maintain the message history as earlier. There is something called generic docs. I will talk about it in a moment. Now let us come to the important method called get response. So now whenever user is asking a query, so what is the first thing we are doing here? We are going to convert the query to relevant embeddings. We are going to use that embeddings by passing it to the vector store and get relevant chunk or relevant documents. So this is the heart of whole RAG implementation. As you know from our previous video, similar text have similar embeddings, different text have completely different embeddings. Now let us say the user is asking about traveling to Goa. This vector search or RAG search will be able to pull relevant offers about Goa. If the user is saying, I want to travel to Paris, this code should be able to pull relevant offers about Paris travel if there is any. So what is the key to it? Converting the question to embedding and comparing this embedding with all the existing embeddings within the vector store. And what is the prerequisite for this? You need to load all of the offers, whatever document you have, we need to preload that to the vector store so that later you can search against it. So we will talk about that as well, how it is preloaded and stuff like that. So let us quickly cover that part. So here is my vector store.py. So in the earlier video, you might have seen it to be empty. So what are we doing here? In the init, the first thing we are doing is loading and splitting the offers. So what I have done, I have created a file called offers.txt which has offer about different locations. And in this vector store.py, the first thing I'm using is something called text loader. So LangChain offers different document loaders for various purposes. It helps you load data from database also. It helps you load data from PDF, documents, TXT files, and stuff like that. So I'm using one of those simple loaders called text loader, where I'm passing the path to my file. I'm loading the data. And here, if you look at my offers file, each location is segregated by this double hash symbol. So that is how I'm kind of grouping all the relevant offers. So here I'm asking it to split based on headers wherever it is finding this double hash. That is what is the destination, and that is how it is going to split this document. So ideally, you should not embed and store your whole document in one shot because it will completely beat the purpose. Because we do not want to give the complete content of the document to the LLM model every time. It will be a lot of unnecessary information for the LLM that will cause to confusion for the model. Second, it will cause performance issues. Your application is going to be slow. Third, you will incur higher cost also. So it is very important you chunk or split your document into smaller pieces and then embed it and then index it into your store. Grouping them also ensures you are able to create relevant embeddings. If you have extremely long amount of text, the embedding which is getting created may not be able to completely convey or store the real crux of this data. So it is very important that we split the data and store. Now, what is the best strategy to split? So it depends on the use case, depends on how your data is. So here in our case, the data is really well structured. It is categorized or separated by this double hash. So I'm going to split by that and store. But what if you have a book? What if you have extremely lengthy web pages? So you can group them by a number of characters or by paragraphs or whatever you. So you need to understand the data and you need to decide how I should chunk or in other terms split my data. And again, when you do the chunking or splitting, there are different strategies as well. Like what are the different chunking strategies you can look about it. And also there are stuff called chunk overlap and things like that, where multiple chunks will have little amount of overlap so that the model is able to better understand what these chunks are. So in our case, we have taken a simpler example. We are not going to have chunk overlap. We are going to split simply based on occurrence of this double hash. So that is what we are having. So then we are preparing something called raw chunks, which basically is splitting the data. And then we are modifying these chunks a little bit. Now, wherever we are having this destination, which is part of the metadata. So as we have told the splitter that it has to split based on double hash, which becomes the destination. So what it would do, so whatever you see here after this double hash, it will move that to a metadata. It will make this the destination and then it will make this the content. But I want the destination and content to be together. So I have made minor changes where I'm basically appending the destination and as well as the current offers, which is basically the content. I continue to maintain the metadata of destination so that we can search with it. So this is what is happening basically where you are loading the offers and splitting them into various chunks. So once I have done that, what is the next thing I'm doing? I'm creating the vector store in itself. So vector store FAISS can run locally. There are multiple options, something like for example Milvus, where you can have a separate independent cluster running where you can index, store and retrieve data at really high speeds. But for our learning, we can use FAISS, Chroma or other options which can run locally in your machine, do not need GPU and they are really fast. So here, to create a vector store, what is the first important thing? You need an embedding model. As I said earlier, the document content first needs to be converted to embedding and then stored into the vector store. Later, when user is asking a question, we will use the same embedding model to convert the question to a vector and then compare and pull relevant data. So here, I'm going to pull something called one of the embedding models from Ollama. So I am using this model, which is a smaller model, would work comfortably in our machine. But let us quickly check this method from the LLM model.py. It's very simple method. I'm just simply returning Ollama embedding and then the model name. No customization, nothing. Again, Ollama embeddings I have imported from the LangChain Ollama package, which you would be already. Now, once we have the embedding model, you have to just pass the chunks what we just created and the embedding model both to this method. Basically, FAISS is creating a vector store based on the documents or the chunks what I'm giving and based on the embedding model. So in return, you are getting a vector store. Great. So going back to our trip planner, so what we had so far is creation of this vector store in itself, right, which we spoke of. Now, once there is a user's question, we are going to use this vector store to do something called similarity search with score. So there are different type of search what you can do. So one is called similarity search, where you use this embedding and try to pull similar data, relevant data. The wordings need not exactly match. As long as they are semantically or meaningfully similar, it will pull the data. And what is a score? So the score tells how similar or how close they are. So I'm going to use this method called similarity search with score. Here k equal to 2 means I want two results. Again, based on your application, based on your testing, you can decide if you want to pull only one result or you want to pull 10 different results and stuff like that. Also, I'm keeping a score threshold. If this is the minimum relevance I want, before which I do not want the results to show. Something like that. So that is the threshold what I have set here. So once I got all of this, I'm filtering for all the documents. There are cases where user is asking a question and I don't have any relevant data about it within my. In that case, the filtered documents could end up being empty, during which I'm falling back to a set of generic documentation or generic offers. If you look at the offers.txt, towards the end, I have a section called general offers for all destinations. So what I want is, if there are no specific offers for a given destination, I want to pass on the generic offers to the model so that it is able to consume it and tell the customer, hey, there is no specific offer, but these are some of the generic offers what we are offering at this point of time. So that is the going back to trueplanner.py. So when there is no relevant data, we are going to give the generic. So whatever documents we have pulled, it could be one or two or multiple. I'm just combining all of them to a simple string. As you know, model is going to work with simple text input, text output. So here I have prepared the complete drag context in pure string format. So now what are we doing? Now we are going to format and create our message. So now we have to look at our updated prompt and then we will come back to this. So here is our updated prompt V4. It is mostly similar to V3 with some changes. I have restructured the way how I'm instructing the model to form the output, but now I'm giving additional instructions as well. I'm telling if there are any relevant destination offers in the provider context, summarize and include them as well. Right? I'm asking them to include in the current offer section. Otherwise, say no. I'm asking it again to provide offers only from the context and do not make up on your own. Models tend to hallucinate. Models tend to think and be innovative. So I'm being very clear to the model that it should not make up its own offer. Rather, it should only give offers from what I have given in the context. And I'm also asking if the user is asking for itinerary suggestions, it can provide a detailed itinerary with day-wise itinerary sections. The section or the structure what we have defined above will work for basic questions like, hey, where can I go? Give me some random suggestion and stuff like that. But if the user is asking for a day-to-day itinerary or plan, this structure may not work. So I'm asking the model that if the user is asking for itinerary, it can go ahead and create a day-wise itinerary. And also, I have seen the model at times hallucinate, not hallucinate, start spitting out whatever it is thinking internally, whatever thought process it is going through. So I have put explicit instruction not to write any internal thinking or reasoning in the model's response. And here I have added this section called offer context. Again, as you can see, I'm using kind of HTML tags here. So there are different strategies we can use to highlight or segregate relevant context what you are offering so that the model is able to better differentiate among this huge text. Hey, what is my instruction? Where is my question? Where is my context and stuff like that. So in an attempt to do that better, I have put this opening and closing HTML tags. Within that, we are going to replace the context in itself. And this context is what is going to come from the vector store, what we were speaking. So going back to trueplanner.py, so basically here I'm doing a system in the prompt format. I'm going to update this context is the RAG context. So what is this context basically? So the context is what you see here. I'm updating that with the RAG context, and RAG context is nothing but what I pulled from the web store. So this becomes my system message. And this message would change every time the user is asking a question. As you know, we are building a conversational application. The user may first ask, hey, give me some suggestions about traveling to Goa. We may pull relevant data. After seeing the response, he might say, hey, what about you give me some suggestions about going to North India or going to Paris? So for every question, we want to pull relevant data and ingest. So that is why we are recreating the system message every time with the updated context. Now, once that is done, I'm invoking the model with this system message and the message history in itself. As you know, message history is multiple terms of user assistant, stuff like that, so that the model understands what has been going on so far. Now we did the RAG, we pulled relevant data. After doing the embedding, we created the updated system message, we combined it with the message history in itself, and then we invoke the model. So once the model gives output, basic processing, we are adding it back to the message history in itself. We are almost there. So once that is done, we go back and print the response to the user. I hope you got a good idea of how things are working with RAG. Now it is time for us to execute our application and see how things are working. So the application is getting ready. So what is happening behind scenes? It is going to do the chunking. It is going to split the data. It is going to the load to the vector store, and all of that is happening. So that when you fire a query, there is not a lot of time spent on loading all of those generic content. Also here, if you see, I'm printing what generic docs we have. So it has detail of the generic offers for all destination. And what is the page content? It basically has a destination again and also the different offers. Like we are giving 1,000 off on first booking, fifth traveler is staying free, then they can pay 30% now, blah, blah, blah. So this is the by default document what we are going to share. There is no other custom document. Now it is time for us to put our specific question and see how the model behaves. I'm saying that I want to travel to Goa. Here, if you see, we have the RAG context. So this is the data what we have pulled from the vector store. See, it pulled data just about Goa. You know, in my code, I had mentioned to pull two results, but it pulled only one. Why? Because I have mentioned a score threshold. So wherever the result is not meeting the threshold, that is not going to be part of my output. So there was only one record which met this threshold, and it has the data about offers which we are giving for Go. So what is happening behind scenes is my prompt would be getting updated. Wherever you see this context section, so there this RAG context would get replaced. And now the model will be able to see the complete prompt, including the context to understand what offers we have. And then it will be able to give an answer with some suggestions, what places to visit and stuff like that. And also talk about this particular context. Here we go. So here we have the model's response now. So it went ahead and said Goa is a wonderful destination and stuff like that. It also went ahead and created a day-wise itinerary as well, what I can do in day 1, 2, 3, 4, 5. It gave me suggested activities, what all I can do, what all different local cuisines I can try and stuff like that. The most important part, it also gave offers. You see, it is able to give this offer that we are offering 20% off on all booking. You can use this code to check out and get additional discounts and stuff like that. Now let us go ahead and ask a follow-up question to the model. Also, give me some suggestions about traveling to South India. Okay, so now I asked about South India. Here, if you see, the RAG context now has two documents because both of them meet our score threshold what we have. The first one is about the Hyderabad destination where it is having some offers and stuff. The second one is a destination within Kerala. So if you see how RAG is working, based on my question, it is pulling relevant results, different results, which is more relevant to the question. So now what is happening? We are going to retain the complete chat history, including what the user asked about Goa and the model's response. But now the context is going to be changed with the latest context what we have pulled. Ideally, the model should be able to understand this and give suggestions on where we can go in Tamil Nadu or Kerala. And ideally, it should be able to read this context, read this offer section, and then give relevant offers as well to the user. Let us see how the model is behaving. Wonderful. Here we have the model's response. So it is telling traveling to South India can be wonderful, and here it is giving some suggestions. It is suggesting that I can go to Kochi, Ernakulam, and a lot of places. Basically, it read this data, and then the model suggested that I can go to Kerala. Right? It also has suggested activities, local cuisines, different travel tips, budget, and it is also giving the current offers. That it is saying that we are giving 20% off on all bookings and stuff like that, right? So it is asking follow-up question, but I hope you got the idea, right? Based on changing users' question or preference, now we are able to pull relevant data instead of providing same hard-coded data to the model every time. If you want, what you can try is instead of implementing RAG, try passing this whole offers.txt to the model. You will see the model getting confused more and more. And also, here the offers.txt file what we have is not very big. In practical scenarios, in production applications, the documents what you have itself could be really huge. It could be 400 pages or 1000 pages lengthy. Practically, you cannot even send that much data to the model. So that is where RAG kicks in and helps. Okay, so that is what I had for today. So far what we have learned, let us summarize. We started with understanding what is GenAI, what is LLM model, how it behaves, what it can do and stuff like that. From there, we built our first GenAI application. We used the basic prompt engineering techniques, and now we have enhanced it to integrate an embedding model and vector store to pull relevant data and basically implement RAG. So now we are at a really good shape where our application does RAG. So now it is time for us to enhance our application in the future videos, to use different tools to help people book tickets, completely book their plan. So in the upcoming videos, I'm going to integrate different agents. For example, travel booking agent, it will check your schedule and a lot of other interesting stuff using agents. Agents has really high potential. So I'm going to implement and integrate all of them in the upcoming videos. So stay tuned and do subscribe to our channel if you want to learn how to implement this agentic AI and other interesting stuff. Catch you in the next video.